Have you ever imagined what it would be like to travel through time? To visit the past or see the future? Time travel is something that has fascinated us for a long time, appearing in movies, books, and TV shows. But is it actually possible? And if it is, what strange problems known as paradoxes would we run into? In this video, we'll explore the basics of time travel and some of the mind-bending paradoxes that come with it. So, let's jump right in. First, let's understand what we mean by time travel. Simply put, time travel means moving from one point in time to another, like jumping from today to tomorrow, or even to a day hundreds of years in the past. But how could this work in real life? This idea comes from Albert Einstein's theory of relativity, which shows that space and time are connected in something called space-time. You can think of space-time like a giant stretchy sheet. Heavy objects like planets and stars bend the sheet. And this bending is what we feel as gravity. And guess what? This bending also affects how time passes. Imagine placing a heavy ball on a trampoline. It makes a dent, right? If you roll a marble near that dent, it'll move toward the ball because the surface is curved. In the same way, massive objects curve space-time, and this affects how time flows around them. Einstein's theory of relativity has two important parts: special relativity and general relativity. Let's break them down. Special relativity. Special relativity focuses on objects moving at very high speeds, especially speeds close to the speed of light. There are two main ideas here. One, the speed of light is constant. No matter how fast you're moving, the speed of light is always the same, about 299,792 kilometers per second, or around 282 miles per second. Two, time dilation. Here's where things get interesting. When you move close to the speed of light, time actually slows down for you compared to someone who's not moving as fast. For example, if you were on a spaceship zooming close to the speed of light, you might feel like only a year has passed, but people on Earth might experience many more years passing. This slowing down of time, called time dilation, is key to the idea of traveling to the future. If you could travel at nearly the speed of light, you'd experience time much slower than everyone else. Now, let's talk about general relativity. This part of Einstein's theory explains how gravity works. General relativity. General relativity shows us that gravity is actually the bending of space-time by massive objects. Remember the trampoline example? The more massive an object is, the more it bends space-time. This bending also slows down time near massive objects like planets or black holes. When we think about time travel, two ideas often come up: wormholes and black holes. Wormholes. A wormhole is like a tunnel through space-time, connecting two different points. If you could enter one end, you might come out the other instantly, even if they're light years apart. It's like a shortcut through the universe, and it could theoretically allow time travel. But wormholes are just a theory right now, and we're not sure if they actually exist. Even if they do, they might be too unstable to use for time travel. Black holes. Black holes are super dense objects with gravity so strong that nothing, not even light, can escape them. If you get close to a black hole, time would slow down a lot for you compared to someone far away. So spending time near a black hole might let you travel into the future faster than normal. Now let's talk about the tricky part: time travel paradoxes. These are weird situations that don't make sense and happen when we think about changing the past. The grandfather paradox. Here's an example. What if you went back in time and stopped your grandfather from meeting your grandmother? If they never meet, one of your parents wouldn't be born, and neither would you. But if you're not born, how could you have gone back in time to stop them from meeting? This is called the grandfather paradox, and it shows why changing the past can be so confusing. Another paradox is the bootstrap paradox. Imagine you go back in time and give Shakespeare a copy of his own plays. He publishes them, and they become famous. Later, you find the same plays and take them back to him. But who wrote the plays in the first place? This creates a loop with no clear beginning or end, making it another strange problem in time travel. There's also the butterfly effect. This idea says that even a tiny change in the past, like stepping on a butterfly, could have huge effects on the future. Something small could lead to big, unpredictable changes, like a domino effect. So, how do we deal with these paradoxes? Scientists have come up with a few ideas. The many worlds interpretation. One idea is the many worlds interpretation. It suggests that every time a decision is made, a new parallel universe is created. So, if you change something in the past, you create a new timeline, while the original timeline stays the same. The Novikov self-consistency principle. Another idea is the Novikov self-consistency principle. This principle says that anything you do as a time traveler was always part of history, meaning you can't create paradoxes because the universe would correct itself. Even though these ideas are fascinating, time travel remains something we can only dream about for now. But it's an amazing concept that challenges our understanding of the universe. What do you think? Would you want to travel through time? And where would you go? Let us know in the comments.